right, now let's run that test. So we already have step 1 done above, but I'll kind of write it again. So h naught p equals 0.24. h1 would be p less than 0.24. And you definitely want to get into the habit of numbering and labeling all your steps. You're going to want to be very clear about what you're doing. Step 2 I'll put over here. Step 2 would be alpha equals 0.01. It says it right here. It says at the 0.01 level significance test this. And remember I said alpha will always be given to you. We're not going to develop alpha. So alpha will just be a set in stone decided thing about what you want your level of significance, which is your probability of a type 1 error, and you go with it. Step 3. Well, let's see. I want my Z0, which is this formula right here. So I'm going to write that formula. And honestly, this is what's happening, but I'm going to write the one on the right because that's the one that's more useful for me. So it's p hat minus p0 over square root p0 q0 over n. And I'm going to show the substitution, and then I'm going to make computers do all the work for me. All right, so p hat, finally, that's the 0.18. See this value right here? 0.18, that's p hat right here. I'm going to do it in blue here. Right, p hat is 0.18. So down here, I'm going to put 0.18. That's the value that's from my sample. Minus, now P0 was the null hypothesis value, which was 0.24, right there. 0.24 over square root 0.24 times 0.76, right? Because we already said Q0 right here, 0.24 and 0.76, P0, Q0. And we're going to divide by N, which was 1068. Now, as much as you are a wonderful math student, you do not want to do that by hand. No, 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 no. You want to make the computer or the calculator do it for you. Now, to do that, you need one thing before I go off and show you how to do it. And I'm going to write it over here in a little note. You're going to need the x value, right? So remember, p hat is x over n. You need the x value in order to be able to run this in the calculator. So we know that p hat is 0.18. We know that x is what we are looking for, and we know that n, we already said, is 1068. Is right there. So then if I want to solve this for x, right, because I need my x value. So we need x for the calculator. And we'll see about StatCrunch. So I think we need it for StatCrunch too, though. So then we multiply by 1068. So you take your calculator or your Desmos, either one, and you take 0.18 and you multiply by 1068, and we get 192.24. And it has to be rounded. So x is 0.18 times 1068, which is 192.24. You must round. Just regular rounding. You can't have 192.24 successes. It's discrete. Either you have 192 or you have 193. So you must round. Okay. All right, so let's look at this on the calculator. Now, I put it on the big table so you can see it. This piece right here, that's the TI-84 calculator. And just like with the confidence intervals, even if you're using StatCrunch, it's still nice to have a way to talk about these things, right? So that's what it is in the calculator, but it'll help you remind yourself what you're doing in StatCrunch. All right, so let's use the calculator first, just because I have the calculator up already. So we're going to go to Stat, we're going to go to Tests, and we're looking for one prop z-test. It's what it said to use right at the top. It said one prop z-test, so that's number 5. So I grab number 5. P0. P0 for us was our zero hypothesis, which is 0.24. So 0.24. And then look at that next line. See the x? It wants x. I need x in order to run the calculator. and you must round it to a near number. If you try to use a decimal, it will not work. So 192, n was 1068. That's my sample size. All right, now you have to choose which is your alternative hypothesis. So it says prop. That stands for P, proportion. So is your proportion not equal to 0.24? That's the first one. Is your proportion less than 0.24? That's the middle one. Or is your proportion greater than 0.24? That's the far right one. Well, we have the middle one because we want less than. So if I go to the middle and then I press enter, then you can see it's dark when I move off of it. Now, if you do not have a color calculator, you won't have the color option. So don't worry about that if it's not there for you. And then I go down to calculate and I press enter. And there it is. That Z line right there. See where it says Z equals negative 4.608? That is this number right here. That is Z. That Z is negative 4.608. Sorry, I moved that off just a little too far. All right, and it gave us a p-value too, right there. See where it says p-value or p equals? That's the p-value. And there's p hat, which is basically 18%. It's rounded, but 18%. And then there's n, which is 1068. So we need the top two numbers, really. We need the negative 4.608 and the p-value, which is the second line, 2.03 e negative 6. And you'll notice at the top of the screen it says prop less than prop less than 0.24. That should match your H1. That should be what your H1 looks like. Proportion less than 0.24. All right, I'll come back for the p-value, but I want to show how to do this in StatCrunch as well. So let me go grab StatCrunch. I'm going to close this. We go to stat. We go to proportion stat. And we go to one sample. And then with data would mean you have a column of data sitting here in StatCrunch that says, you know, yes, 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 no, 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 I don't use cash. No, I don't use cash. No, I don't use cash. Yes, I use cash. No, I don't use cash. Right? You need a column of data. We're not going to have that. So we're going to go with summary. So we click with summary. And there it does. See, it needs X. X is the number of successes. So it does need X. It needs the 192. So we need it for both the calculator and for StatCrunch. So we could actually write that. We need it for calculator or StatCrunch. I'm just going to put stat C, you know what I mean? All right, the number of observations I had was N, which is 1068, right? So that's X, that's N. It's going to form my p hat for me. We're doing a hypothesis test now. In chapter 9, we would click confidence interval, but in chapter 10, we leave it a hypothesis test. And we have to select what our hypotheses look like. And I think it's a little less confusing in StatCrunch than it is in the calculator because it actually looks like it looks like on your paper. So let me move this over so you can see. Move this down. So I have P equals 0.24. And notice once I put that in there, it knows the next one is the same number because it has to be the same number. And then I choose which way I want this to go. And I want a less than. So I clicked on that little arrow and I made it a less than. And that's it. And then I just click compute. And there you can see it. There's the negative 4.608 right there. All right, step 3 is done. Step 4. I need to draw a picture that matches what I'm doing. So since my particular test is a left-tailed test, you can see it's got a less than right there. So it's a left-tailed test. So this is the picture I'm going to draw. But my Z0 is not this far over. My Z0 is at negative 4, which is basically off the screen, right? So Z0, I'm going to draw my picture. Here's my normal curve. Remember, this is 0. And then the inflection point is at negative 1. And then, right, so here's negative 1. Here's negative 2. Here's negative 3. We're at negative 4.6. So here's negative 4. So negative 4.6 is like here. That's Z0, which is negative 4.608. Yes, label it. Then that itty bitty bitty tail, which is basically, it's super, super small. That's your p-value. Now, the calculator and the StatCrunch say different things. So let me show you what the calculator says? The calculator says it's 2.03e negative 6. Let's think about what that is for a second. It's really small. 2.03? Let me see it one more time. Yeah, 2.03e negative 6. I'm going to put it over here for right now. Okay? And what that means is that this decimal has to move 6 spots over. So it becomes 0.000000203. It's super, super, super small. StatCrunch doesn't bother. StatCrunch is like, look, if you have that many zeros, I'm not going to be down for that. All I'm going to say is that it's really, really small. It's less than 0.0001, which is basically smaller than any alpha you're going to have, right? So I do not mind either way. So if you want to say what it is because you're using the calculator, fine. If you want to say, hey, that p-value is less than 0.0001, fine, right? Either one will work. So it's really, really small. That's what you want to know. So if you want to use the calculator, fine. If you want to use StatCrunch, fine. Whichever one of these you want to write is fine. All right, now step 5. We have a decision to make. So we've drawn our picture. We'd put it farther over because it's way over there at negative 4.608. And if our p-value is low, less than alpha, we will reject h0. Well, our p-value is less than 0.0001. What was alpha? Alpha was 0.01. Well, if your p-value is really small, so small that it has more than 3 zeros, right? It has actually 5 zeros, then it is less than alpha. So if you want to, it's really easy if you do this in the calculator because you can say, hey, my p-value was 0.000002, that is less than alpha. Okay. If you're with StatCrunch, you would say my p-value is less than 0.0001, which is less than alpha, and alpha was 0.01. Either way you want to write it. So this would be StatCrunch. This would be the calculator. But they all lead to the same thing, which is that you are going to write, one way or another, reject h0. Right? So you reject h0 and you have to write why. So if you have a calculator, you write this. If you have StatCrunch, you write this. Either one is fine because they're both showing that you need to reject h0. Same thing with over here. If you have a calculator, you write this. If you have StatCrunch, you write this. Either one is fine. Now, finally, the end. All right, so we've made our hypotheses. We have our level of significance. We found our z-score. Oh, you better make a note to yourself. You find with StatCrunch or one prop z-test, a one proportion z-test in your calculator. Either one. Right? So you don't want to do that calculation by hand. Then you also find these p-values with StatCrunch or your calculator. So find with technology. You're not going to be able to find them on your own. You're going to have to find them with technology, either the calculator or StatCrunch. And then you make your decision over here. You rejected h0. And finally, the pièce de résistance. You write your conclusion. So your conclusion would be there is significant evidence because we did reject h0. Remember that table from section 10.1. When you reject h0, then there is sufficient evidence to support the claim. It's on page 225 in this current semester. I don't know if it'll stay that way forever, but it's right here. When you reject h0, there is sufficient evidence to support the claim. Okay? So we will write that. There is sufficient evidence to support the claim that, now what were we trying to claim? The proportion of people that pay with cash is less than 24%. Adult Americans that pay for almost all their weekly expenses with cash. It's the H1 that's going to get you because you have to write so much, right? It's the proportion of adult Americans that pay for almost all their weekly expenses with cash is less than 24%. You're writing out H1 in words. And this came from that table in section 10.1. Make sure you have your directional word in there. So we thought it was less than 24%. We thought it had decreased since its old value of 24%. And there was sufficient evidence to support that claim, that it has gone down, that it has decreased, the proportion of Americans that pay for things with cash. Now, hypothesis tests are a big problem, right? Lots of steps. But remember that the piece in your exam notes packet walks you through everything. It's all on here. The formulas, which hypotheses you are doing, how to draw your picture. It's all here. You just have to follow it, right? And do step by step by step. If you do step by step, you won't go wrong.